Right now, under your feet, there's a place hotter than the surface of the sun, and you've never even come close to seeing it. Humanity's deepest hole ever drilled only scratched 0.2% of the way there. Every mile you dig would get more violent than the last, until pressure alone could crush a submarine like a soda can. And somehow at the very bottom, there's a solid metal ball the size of Pluto, spinning slightly out of sync with the rest of the planet. So let's actually do it. Let's dig straight down and find out what happens to you. You start at the surface, shovel in hand, and honestly, the first few miles are almost boring. The crust, the layer you're standing on right now, is thin. Under the continents, it's roughly 20 to 40 kilometers thick. Under the oceans, it's often less than 10. That means if Earth were an apple, the crust would be thinner than the skin. You'd expect the ground beneath your feet to feel solid and permanent. It's actually the flimsiest part of the whole planet. Keep going and things heat up fast, literally. For every kilometer you descend, the temperature climbs by roughly 25 to 30 degrees Celsius near the surface. That's called the geothermal gradient. Here's the part that actually surprised scientists, though. When the Soviet Union drilled the Kola Superdeep Borehole, the deepest hole ever made, models predicted it would hit around 100 degrees Celsius by 12 kilometers down. Reality had other plans. At 12.2 kilometers, it measured a scorching 180 degrees Celsius, hot enough to bake bread on the rock walls around the drill. The heat wasn't just uncomfortable, it was the reason engineers had to stop. The rock got so hot and plastic it started flowing like thick tar and closing the hole behind them. So step one of digging to the center of the Earth is admitting our best drilling technology gave up at 12 kilometers, and the center is 6,371 kilometers away. You haven't even finished the appetizer. Let's say you had a magic drill that didn't care about heat. Keep descending and you'd hit the mantle, the thick middle layer that makes up about 84% of Earth's total volume. This is where things get weird, because the mantle isn't liquid the way lava lamps make it look, it's solid rock. It just flows incredibly slowly over millions of years, like the world's most patient toothpaste. You wouldn't swim through it. You'd need to grind through solid stone under pressure that would flatten a modern submarine into a coin within seconds. And here's a fun one. That pressure isn't just uncomfortable, it's the same force that turns ordinary carbon into diamonds. Most diamonds mined on Earth's surface formed roughly 150 to 200 kilometers down in the mantle, squeezed into crystal form, then shot upward over millions of years by violent volcanic eruptions called kimberlite pipes. So technically, every diamond ring on the planet is a tiny, extremely lucky escapee from the exact hellscape you're currently drilling through. Keep going past 2,900 kilometers and you hit the outer core, and this is where your magic drill would really start earning its paycheck. The outer core is liquid metal, mostly iron and nickel, swirling and churning at temperatures around 4,000 to 5,000 degrees Celsius. This isn't a minor detail. This liquid metal ocean spinning beneath your feet generates Earth's entire magnetic field through a process called the geodynamo. Without it, you wouldn't just lose your compass. Solar radiation would strip away the atmosphere over time, the way scientists believe it happened to Mars. So every step you take on the surface, you're being protected by molten metal you'll never see, swirling thousands of kilometers below you right now. Finally, at the very center, roughly 5,150 kilometers down, you'd hit the inner core. Here's the part that sounds fake but isn't. Despite sitting at temperatures close to 5,400 degrees Celsius, roughly as hot as the surface of the sun, the inner core is solid, not liquid. The pressure down there is so extreme it physically forces iron atoms to stay locked in place even at sun-level heat. It's that same solid metal ball we mentioned earlier, roughly the size of Pluto. And in 2023, scientists confirmed something even stranger. It doesn't spin at exactly the same speed as the rest of the planet. Sometimes it drifts slightly ahead. Sometimes it slows down and lags behind. There's a slow, silent ball of iron at the center of your planet quietly doing its own thing, and you feel absolutely none of it. Obviously, you're not making it there alive, but let's have some fun with the math anyway. If you somehow fell straight through a perfectly drilled tunnel with zero air resistance, gravity would actually work in your favor for a while, then work against you the whole way back. And physics says the round trip would take around 84 minutes. That's not science fiction, that's a real calculation based on gravitational acceleration, and it means a train through the Earth's core could theoretically beat any flight on the planet for time, assuming you don't mind the small detail of instantly vaporizing. Speaking of vaporizing, let's talk about why nobody's actually attempted this seriously. Because it's not for lack of ambition. Engineers really did try, spending over 20 years drilling that single hole in Russia, and it still didn't get past the crust. The deeper you go, rock behaves less like solid stone and more like extremely stubborn dough, squeezing inward and destroying equipment faster than it can be replaced. Even the most heat-resistant drill bits we've ever built start failing within hours at those depths. We've sent robots to Mars, 225 million kilometers away, more successfully than we've drilled 13 kilometers straight down. That's not a joke. That's just how brutal the physics gets underground. Let's talk pressure for a second, because most people underestimate just how absurd it gets. At sea level, you're already living under about 1 atmosphere of pressure without noticing, roughly 14.7 pounds pushing on every square inch of your body, balanced out by the pressure inside you. Dive to the bottom of the Mariana Trench, the deepest point in Earth's oceans, and that number jumps to over 1,000 atmospheres, enough to crush most submarines that aren't specifically engineered for it. Now compare that to the center of the Earth, sitting at roughly 3.6 million atmospheres. That's not a bigger number in the same category. That's a completely different universe of physics. The kind where atoms themselves get shoved into configurations they'd never form on the surface, which is exactly why solid iron can exist at temperatures that would instantly vaporize it up here. And here's a detail that sounds like a rejected movie plot but is completely real. In 2003, geophysicist David Stevenson at Caltech seriously proposed a way to actually probe the Earth's core, not by drilling, but by pouring tens of thousands of tons of molten iron into a crack in the crust and letting gravity do the work. The iron, being denser than surrounding rock, would theoretically sink toward the core at roughly 5 meters per second, dragging a small sensor probe along with it and reaching the core in about a week. It never got funded or attempted, partly because nobody could guarantee the sensor would survive, and partly because, understandably, pouring molten metal into the crust makes a lot of people nervous. But the fact that a serious scientist proposed sinking a probe into the planet like a fishing weight tells you everything about how differently you have to think once you're dealing with forces this extreme. Almost everything we know about the deep Earth doesn't come from digging at all. It comes from earthquakes. When a major earthquake happens, seismic waves ripple through the entire planet, and the way those waves bend, speed up, slow down, or disappear entirely as they pass through different layers tells scientists exactly what's down there. The same way an ultrasound uses sound waves to see inside a human body without cutting it open. Every layer we just described, the crust, the mantle, the liquid outer core, the solid inner core, was mapped almost entirely through listening to the planet ring like a bell after violent tremors thousands of kilometers away. So no, you're never actually digging to the center of the Earth. Your body would be crushed within the first few kilometers, cooked well before that, and there isn't a material on the planet that could survive the trip intentionally, let alone comfortably. But the wild part is that we've still managed to map the entire 6,371-kilometer journey anyway, layer by layer, without ever setting foot below 12. We know there's a slowly drifting ball of solid iron at the heart of your planet right now, spinning to its own private rhythm, generating the invisible magnetic shield keeping the sky above you intact. You'll never see it. You'll never touch it. And every single day without noticing, you're standing on top of it.